it wants to grab electrons. It's way more electronegative than carbon. So in this tug of war between carbon and oxygen fighting over the electrons, oxygen's going to win. You think of all these trees and shrubs and things, these are reduced things. There's lipids in here, tons of carbohydrate. The cellulose in these trees is just a close cousin of starch. It's a polymer of glucose, right? It's just linked a little differently. But here's glucose burning up in the presence of oxygen, donating electrons to oxygen. We're doing the same thing with our carbohydrates. We in fact talk about burning calories, right? We burn calories. We're burning glucose. We're doing this kind of combustion reaction in slow motion. Instead of all the electrons going to oxygen in like one concerted reaction, a plasma, we're taking the electrons out one step at a time, a pair of electrons at a time, running it through this system to extract energy. And we'll see different forms of it. We're already seeing the energy being transduced into a proton gradient for starters, instead of just giving off heat like it is here. But the thermodynamics is the same. Electrons are running from the reduced carbohydrate to oxygen, because that's the thermodynamically favored direction towards the electronegative oxygen. So we save some of that energy as a proton gradient, pumping it out. It becomes negative inside, positive on the outside. And the protons don't just stay out there. Eventually they're allowed back in. They come back in through this thing that's called the ATP synthase. Another name for it is the F1FO ATPase. Means the same thing. It has these two major components. There's a large component buried in the membrane, so we call this an integral membrane protein, of course, buried hydrophobically in the lipid bilayer. And then the part that sticks out into the matrix, so FO is here, and then sticking out into the matrix is this stalk with a little head on it called the F1 particle. And that's what ATP is for. If you break up mitochondria using ultrasonic energy, you decimate the membrane structure. These little particles, in fact, fall off. People have crystallized them, got a good X-ray crystallography structure out of them. It's got this repeat structure of, there's three alpha-beta pairs, alpha-beta, alpha-beta, alpha-beta. There's this gamma thing coming up the middle. You can see the protein structure, familiar structures of alpha helices, little anti-parallel beta sheet structure and so on. These are just normal proteins. But in the crystal structure, they noticed, hey, there's an ATP molecule there. And over on this alpha beta diagram, ADP here, ATP there, that one's empty. Here's a top view of it.